Team Phoenix presents The Blink of an Eye, a single button virtual keyboard and mouse. Our vision.
The vision of The Blink of an Eye is to enable, empower, and encourage quadriplegics, paraplegics, and other categories of physically challenged persons to perform simple routines like communication, to use computers and similar devices, and to move around without any assistance. Our inspiration. A strong felt urge to create a system which would have far-reaching consequences in liberating, comforting, and enabling physically challenged people to live life better with utmost ease has inspired us to create this module. Our mission. Vision, vocal, auditory, and locomotory impairments make up the complete list of physical disabilities. The most challenging one of these is the locomotory impairment that is mainly caused due to strokes, paralysis, accidents, etc. The mission of The Blink of an Eye is to tackle all the above mentioned disabilities or even combinations of them and enable such patients to carry on with their daily routines easily. An overview of our module. The blink sensor is interfaced with the computer via SPRIO 9626 development board. The computer is coupled to a GSM module via USB serial interface. The blink sensor with the visual feedback from the computer simulates a virtual keyboard and mouse. The laptop is to be mounted on a wheelchair which is fabricated with DC motors, relay H bridges, and proximity sensors. Now, let us look into the blink pattern sensing capabilities of our sensor.
Short blink.
Short.
A long blink.
Long.
Now a complete sequence.
Short. Long. Long. Short. Long. Short.
Second sequence.
Long. Long. Short. Short. Long. Long.
The features of Blink of an Eye. Predefined template selection for quickly converting text to speech. Text to speech via QWERTY keyboard for the composed text to speech according to what the user wants to say. Virtual mouse and keyboard to enable the use of a computer. Blink-based locomotion module to achieve locomotion with the least demanding physical activity. Communication via SMS, another feature. This is how the main user menu looks like. The menu consists of options such as templates, keyboard, computer usage, and movement. Template selection. In this mode, a row is first chosen by a blink and then the column so that a particular option is selected. This is an example of auto-toggling, where the row or column toggling would stop only once a blink has occurred. A demonstration.
Hello. I like the film Avatar.
As you can see here, there are 5 slots left for the user to add his own set of favorite films, where a double blink would allow him to access the keyboard and edit, add, delete templates. The virtual keyboard. This is a basic QWERTY keyboard where the braille addresses are assigned to each letter. A dot stands for short blink and an underscore stands for long blink. A word is spoken out only after a single short blink occurs. Now let us see how the keyboard is used.
Boolean.
Computer interface. We will now see how the computer can be used by this module. A dynamic crosshair is achieved through two picture controls. The first blink would stop the horizontal line, and the second would stop the vertical line to achieve the crosshair mode of selection of icons and folders.
Once the Use Computer feature is selected, the window of LabVIEW is minimized. A screenshot of the desktop is captured, the window of LabVIEW is maximized, and then the captured desktop image is displayed in LabVIEW. The point to be clicked at is determined by the dynamic crosshairs, where a single blink stops the horizontal and vertical lines. The window of LabVIEW is minimized. A mouse click is triggered at the point determined. After the clicked folder is opened, a screenshot is captured again, and the screenshot is displayed in LabVIEW. This sequence of events achieve a mouse click, and any number of mouse clicks can be inputted.
Using a browser. Once the browser is selected through the crosshair selection mode, a double blink would enable the user to access the keyboard and type the keywords. Once the text is built, it is entered into the text area of the browser, where it has to be copied through the same crosshair selection. The user can also store his blink sequences to increase his browsing speed, and then assign blink sequences to access the same. Emergency SMS. The user can also send an instant SMS to the caregiver during an emergency by inputting a quadruple short blink sequence. Let us see how.
We will now see how direction selection can be achieved. Here is a demonstration on how the motors, which would be fabricated onto the wheelchairs, can be operated. Direction control is achieved through a relay board which is electronically excited by the microcontroller. The first relay provides excitation current to both motors with starting resistances. The second and the third relay cut out the starting resistances of the right and the left motors respectively. In this demo, the shaft of the motors start rotating even with the starting resistances due to the absence of load. The delay in the operation of the relays which cut out the resistances is set to 1 second. The operation of the motors start only if it is safe to start. That is, if no obstacle is detected up to at least a meter and the presence of floor is confirmed. This is done by the proximity sensors. We have simulated the blink sensor with a push button. A normal click of this button corresponds to a short blink. The state of the eye is simulated by this virtual LED. The LED is on to imply that the eye is closed, off to imply that the eye is open. Here, the graph of the voltage values of both the floor detector and the obstacle detector have been displayed. A single blink here toggles between directions, but there is no motor output. A double blink, however, selects a direction and motor output can be seen. To turn left, the starting resistance of the right motor is cut out. To turn right, the starting resistance of left motor is cut out. During locomotion, if an obstacle is detected, the motors are stopped. The same happens if the absence of floor is confirmed.
Wheelchair fabrication. The wheelchair is fabricated by altering the wheel assembly of a readily available wheelchair and incorporating a DC motor assembly, cycle sprockets, and free wheels. The shaft power is transferred to the wheels by a cycle chain drive system. Now let us look into the challenges faced and possible solutions. Literacy is required to use speech-to-text functionality. Text is synthesized via detailed pictorial classification. Slow mouse traversal. Predefined sequences are stored to minimize mouse usage. What if a person cannot stop the module by blinking again? Disability to blink during locomotion. Obstacle sensors can assure the safety of the user. Slow typing speed. D9 predictive text can be incorporated with the same logic. The logic involved here would be the same, but the number of blinks per word would be reduced by a very significant percentage. And the following braille addressing shows how common windows in a computer can be traversed through. The user can choose to start and stop recording the sequence of button pressings and click events and then assign a blink sequence to initiate the recorded sequence. The scope of the blink of an eye. The module has been developed in the Windows environment. If the same is done in the Android environment, the total fabrication cost is less than half of a commercially available motorized wheelchair without our module, the blink of an eye. Why our module? The module requires the most simple function, that is, the blink of an eye. The data acquisition and interpretation is almost an error-free process as it involves a single Boolean value monitoring. Thus, the module is highly robust and usable. The blink of an eye is fast, accurate, and offers a very wide range of solutions. The blink of an eye is safe, implementable, and designed to make the futures of quadriplegics, paraplegics, and other categories of physically challenged persons less difficult and more comfortable. The blink of an eye liberates passionate minds trapped in disobedient bodies to express themselves.